For those of you I have not met yet, and I know we have some new folks joining us online just for this session from actually around the world, the International Rules as Code community is coming out strong to join us. They're really excited about this work. My name is Ariel Kennan. I'm the Senior Director for the Digital Benefits Network at the Beeck Center here at Georgetown. And I have been so lucky to be able to be doing research on rules as code for the last couple of years, including in partnership with our colleagues at the Massive Data Institute, with my colleague Lisa Singh, who you'll hear from in a minute, as well as Angelika Gokar-Gossman. And we have been looking at how technology can be applied in this space and how policy gets implemented in these benefit systems. And we've also launched our Rules as Code community of practice, which you will hear more about, which Tina Amper is our community advisor for. I'm going to go through this incredibly quickly, but knowing that we have people from a variety of backgrounds, and so just giving you a little bit of definition setting on what is rules as code, what are we actually talking about. The Organization for Economic Cooperation and Development, or OECD, has a fantastic report that they issued a couple years ago. I'm also hearing an echo from our online folks. Thank you. And in that definition, they talk about an official version of rules, e.g. the laws and regulations, in a machine consumable form, which allows rules to be understood and actioned by computer systems in a consistent way. For benefits eligibility, we imagine this applied in a format that looks like if there's a policy, law, or regulation, that there would then be plain language logic that's available, as well as that computer consumable code in a standardized syntax, which those together with the official policy document can act as an official versions of the policy that all reinforce each other, that can then be integrated into systems like benefits eligibility screeners and application systems. If you are excited about this work, on the Digital Benefits Hub, soon to be the Digital Government Hub, we have an entire page of resources devoted to digitizing policy and rules as code. It includes our research as well as research from around the world. These demos will live there going forward as well. And if you're really excited about it and want to come engage in a community of practice, we have over 100 people in our very active rules as code community of practice. There's over 100 people in the Google group, and this demo day and prototyping challenge are a direct outgrowth from that community of practice, where we heard the real interest in exploring how generative AI could apply. And so I am going to welcome my colleague Lisa Singh up to help us talk about the challenge.
So, thank you so much, Ariel. First, super excited to be here today. I'm a computer science professor and a public policy professor, so this is like my jam, and I'm so excited to share this challenge with all of you. So let's start out talking about what our goal was. Our goal was to invite different people from all over to experiment and test how generative AI technologies, and these are any technologies, large language models in particular, could be used to translate government policies for U.S. benefit programs into either the plain language that Ariel was speaking about, software code, or other assets as well. And I think part of our rationale in doing this was really to start understanding what our community and those outside of our community were doing in this space. Are people using these models? Are they not? What are they learning, and how can we all learn together? Because we weren't at a stage where we were sure how well this would work in the pipeline. People spend hours and hours translating policy into their systems, and if you can take even a piece of that process and automate it using some of the new technologies that are out there today, we wanted to know, and we wanted to hear how different people were doing that, whether they were using a human in the loop, whether they needed to use more sophisticated reinforcement learning, or whether they were just able to, out of the box, use LLMs. And so this challenge was a first step at understanding that. Okay, so we seeked experiments to test the use of generative AI in the following scenarios. We wanted to look at the translation of U.S. policy public policy benefits into software code. We also wanted to look at it into plain language logic models, and then any translations between coding languages that people were working with. And finally, we asked for recommendations for different additional scenarios that could be useful in this context in terms of policy implementations through digitization. The challenge focused on U.S. public benefit programs, SNAP, WIC, Medicaid, CHIP, and so on. And I'm going to try to go a little faster just to keep us moving. So what did we do? So in April and May, we asked teams to apply. We selected a set of teams in June. We hosted summer touch points all summer long in order to connect teams and coaches and have conversations among the teams. And then all that work, everyone kept working on their prototypes and working on their code bases, and here we are today to see the fruits of all that labor. And then our goal will be in early 2025 to co-author and publish a report that summarizes the challenges, activities, and documents all the different findings that we see today. All right, so we were very lucky to have a set of experts who were our coaches through this whole process. Andrew Gamino Chung is the co-founder and CTO of Trustable AI. Meg Young is the participatory methods researcher at Algorithmic Impact Methods Lab. And Harold Moore, he's the director for the Opportunity Project for Cities here at Beck. And then Michael Rebar is the principal associate at Social Policy and Economics Research at WestStat. So really nice, diverse group of coaches that could help with different aspects of the policy side of human-centered interface design, as well as the technical LLM side. So I would love if we could get, well, let me pause a minute. Be safe. I hope your leg's okay.
I'm gonna take care of her.
Okay. All right. So most of our coaches are online right now and joining us online. So we'll get a shout out from them later on. Finally, we would like you to look at these different demos and vote on a Community Choice Award. We want your help. We're excited about this award. And so as you listen to the demos from the teams, figure out take note of which ones are your favorites so you can vote at the end. Go ahead and scan the QR code and we'll launch the poll in just a moment. Sorry. Here? Give everybody a second. All right. Sounds good. All right. Okay, so we had 12 teams participate in all the steps of the prototyping challenge, and it is now time for the demos. Each of the teams will present for 5 minutes, and they're going to present back-to-back without any breaks, just so that we can get through these a little bit faster, and then we'll have the opportunity at the end for you to meet with them after the session ends to talk and ask them more questions. So with that, let's get started.
Right?
Go for it.
Let's do it. Hi, my name is Alex. This is Jerry. We are representing BDO Canada here, and we're here to talk about Policy Pulse. So a bit about BDO Canada. Here's a slide about our consulting firm. You can read all about it. Lots of great statistics of how great we are. However, I want to talk to you about something a bit more personal than that. I myself, my brother, he recently passed, was the recipient of government benefits all throughout his life because of disabilities. Because of these policies, because benefit policies are really important to me, and it's directly connected to my family, it directly connects to my work as well. That's why Jerry and I wanted to share with you today the use cases you do, the work you do in here today is really, really important in creating solutions for public good, and how do we actually all support you all today. And with that, I want to kind of talk about our use case specifically. So this is Jamie. Say hi to Jamie. She's our... Oh. Perfect. So Jamie is our senior policy analyst. She's dedicated in crafting effective policies that serve public good. She's kind, she's considerate, and she recently got a new job with the USDA, specifically working on SNAP. All of a sudden, Jamie's director comes to her and actually says, okay, we got to expand SNAP eligibility to include homeless shelter deductions, to have them include families, and not only that, also include them to have to support them a year after they've been housed. So let's for a moment empathize with Jamie and her monumental task. We broke this down into 3 particular sections. First, we wanted to understand the legislative and regulatory requirements pertaining to this, so the nitty-gritty bits and pieces of it, being able to simplify all the legislation, all regulation, and be able to produce meaningful and summaries for shareholders, as well as individuals that cared about this. And last but not least, to be able to actually do this from a technical implementation process, so implementing legislation and regulation. And from that, we proposed this idea called Policy Pulse, a tool to help senior policy analysts to do a first pass on learning legislation and regulation. So using LLM and embeddings that have relationships built into them, what we can use with these particular systems is find passages that relate to the homeless shelter deduction for Jamie in the regulations and legislations, find all the relevant sections that require policy changes, and also find the places where it actually is contradictory so that she can go and fix them, and start pontificating and thinking of how do we actually change these particular pieces of policy, specific legislation and regulation, to encapsulate this and to move this forward. In addition, we need to control for hallucinations. LLMs do hallucinate. So for systems like these, and for our system specifically, we provided citations specifically for this, for the sections of the legislation, as well as the paragraphs and subparagraphs for the regulations. But now talking about our third use case, the implementation side of things. How do we actually turn this into code that is implementable for systems? And that, I'll pass it to Jerry.
Thank you, Alex. So one of the key findings was that RAG models did not really generate code all that well. We found that it wasn't able to capture the level of detail that was required for code. What ended up working, what we found that worked, was actually passing in text directly into the query and then asking these models to generate the code. And so for this, we use Gemini 1.5 model, which has a large input token window. And we used this input token window to pass in the entire regulatory document as the first query to use as context in the subsequent parts of, in the subsequent sections of subsequent steps. And then in the next step, we passed in different sections of the regulation and asked the model to convert those sections to code. And then with the final sections of Python code that we've got, we've stitched them together and then generated the entire script that covers the entire regulation. We found that this led to an 80% accurate conversion of the regulation to code, and we validated this by passing in this to, we passed this into ChatGPT and asked it to evaluate how well the generated code matched the text that it originally originated from. And so here's an example of the regulation and how it looks like in Python code. You can see that the highlighted text is captured as conditions and as thresholds in the code. Now, we envision this code as a really neat starting point for Jamie, for policy analysts like Jamie. We envision this to be a tool to help Jamie to make better decisions and to evaluate how to correct if there are any discrepancies between the regulation and the code. And we believe that this can reduce the time it takes to implement policy. Previously, if it took Jamie years to implement this policy, we think we can bring it down from, we think we can begin to think of it in terms of months or even weeks, thereby bringing these programs to the most disadvantaged of people as soon as possible.
Awesome. So, to kind of summarize all this and the things that we learned from an LLM perspective, RAG with property graphs are great for general summaries and queries, but large context models really provide great benefits when doing analysis for complex related documents such as legislation and regulation. So at the end, these things are what we learned so far, which things are moving really, really quickly. Every single day there's new papers on how do you actually do these particular types of systems. But it's a great opportunity to start learning and start implementing tools and techniques for government to trying to do a first pass in analyzing all of this. But at the core forefront, and something that we really want to stress is that responsible AI usage comes top of mind. Controlling hallucinations, understanding data privacy, guardrails, as well as in Canada specifically data residency issues. These always will be top of mind for us when we build systems like this, especially in serving the public. And at the end, a lot of these tools and techniques are brand new, and this is just the beginning. So come talk to us, and thank you so much for your all the time. Thank you.
All right. Good afternoon, everybody. My name is Tom. I'm a developer at Code the Dream, and this is Luis, our benefits expert. A little bit about Code the Dream. We are a growing national nonprofit focused on inclusive opportunity and innovation. At Code the Dream, we envision a world in which innovation comes from all of us and benefits all of us. Today, I'm very excited to share with you the work we've been developing. Public benefits programs are complicated while the information is not easily accessible online in any centralized way. So we're introducing our RAG-based AI assistant to support community benefits navigators. With our tool, navigators can quickly get access to the benefits. With our tool, navigators can quickly get access to public benefits programs and quickly get answers about its client's eligibility, streamlining the process and improving outcomes. But how do we know that our application is reliable and is actually beneficial to people who will be using it? We constructed a testing suite that focused on the accuracy of information and also, so we constructed a testing suite that focused on the accuracy of information, and we created a data set that contained questions and expected answers that we will most likely see in production about benefits. Then in each run, we tested different prompts, models, and consistency under different conditions. After that, we have a human subject matter expert review the responses and LMM scoring for accuracy. We then combine both of the scores and see the overall performance. Now I would like to introduce Luis to talk more about our research and findings.
So for the Policy2Code challenge, we wanted to test two hypotheses. First, would our retrieval augmented generated LLM-based model, so our RAG model, with a prompt limiting the response to information with the program docs, provide a more accurate response than the assistant by itself? And second, would the RAG-based model follow the prompt limiting responses to information in the program docs when we purposely didn't provide any program docs? So would it just make stuff up? We first ran the test, our standardized test questions through the AI assistant with no prompt and no program docs. So this is not the RAG model. This is just the assistant by itself to establish a baseline. We found that it was not very accurate, only about 50% accurate when scored by another LLM and 30% scored by a human expert. Second, we ran the test questions through our RAG model with a prompt that instructed the assistant not to answer unless it could find the information in the program documents, and we purposely didn't upload any program documents. We hoped the model would say, sorry, we cannot respond because we do not have this information in the program documents, but we found that it often did provide a substantive response, and like the first test run, these were not very accurate. Finally, we ran our test questions through our RAG-based model with the same prompt limiting responses to information in the program documents, and we uploaded a limited number of program documents for the North Carolina Medicaid program. We were very pleased with the accuracy of our model. Even with minimal program documents, we achieved 90% accuracy when scored by an LLM, and that only decreased by about 2%. Oh, I'm sorry, I have not been flipping my slides. This was our second data set. This is our third. So you can see that we had about 90% accuracy when scored by the LLM, and that only decreased by a couple of points when scored by a human expert. So to summarize our findings, in response to our first question, we found that yes, the RAG-based model with program documents is more accurate than the AI assistant ourselves. For our second question, we found that no, the AI does not follow instructions and continue to provide substantive responses when it shouldn't. So for our final insights, initially, we imagined this tool for the general public, but we decided to redirect our use case to focus on community benefits navigators for a couple of reasons. The first is a lot of the best practices around risk management and misinformation suggested that AI-generated information should be run through human experts. And then the second is that we want to expand, provide a reliable and accurate tool that will help expand the capacity of experienced navigators to serve more people by being able to more quickly access information, and also limit the time and training and onboarding of new benefits navigators to help get them up to speed more quickly. So moving forward, I think we would improve our testing by soliciting test questions directly from community benefits navigators to make sure we're really testing information that is applicable, and also adding a user feedback feature on our ultimate model. We would also like to test for criteria beyond accuracy, which is all we tested for now, like readability and understandability. And we'd also like to look at how the number of program documents, either reducing or chunking methods and different things like that, impacts accuracy. For BenCon, we just focused on questions about the Medicaid program in North Carolina because of the short timeline, but we'd like to expand this to all benefit programs in North Carolina and create a model that's easily adaptable to other states. So for our artifacts, I will pass back to Tom.
And to summarize, this is why we discovered there are limitations having LLM evaluating other LLMs. So we follow the methodology of having human verify LLM. And for evaluation metrics, we find these useful and apply them for all of our human evaluation. And this is the end of our presentation. Thank you.
Hi everyone, we're Team Hoya's LexEd Codex, a collaborative effort between the Beeck Center, the Massive Data Institute, and the Center for Emerging Technology and Security at Georgetown. We are investigating how AI chatbots and other large language models perform different tasks that support rules as code adoption for SNAP and Medicaid policies. To do this, we experimented with the policies from several states, and today we're going to focus on Oklahoma's and Georgia's policies. Our experiments use well-known AI chatbots as well as other large language models.
Thank you, Jason. Yeah, I don't think I need that. For our first experiment, I'll need it. For our first experiment, we evaluated how well can AI chatbots answer general SNAP and Medicaid eligibility questions and what factors affect their responses. Here's an example of one of the questions that we ask about eligibility, and here's the sample response of the type of response that we're looking for. After grading over 100 questions, we found that both chatbots are able to cite sources and have internet access. However, this doesn't guarantee that the data that has been trained on is actually accurate. For Snap Georgia, only 47% of ChatGPT's responses were complete or comprehensive, and for Gemini, only 24%. Therefore, ChatGPT and Gemini are tools that are still far from being completely reliable when it comes to current information on benefit eligibility policies. For our second experiment, we evaluated how well can GPT-4o API generate accurate, complete, and logical summaries of benefit policy rules in response to different types of prompts. Here's our methodology. First, we obtain the policies, then we build a RAG environment, then we process policy data, generate the prompts, and finally evaluate the responses. Taking a closer look to our rubric, we can see we've divided by 3 categories: accuracy, completeness, and relevance, scoring from 1 to 5. Now we're going to take a closer look to the specific rubric applied to these AI-generated responses. So accuracy. For Georgia SNAP and Oklahoma Medicaid, we can see the rates are 74% and 89% respectively. And while these high scores are due to the fact that we fed the accurate documents to the LLM, we also have to recognize that there were some errors in the responses, which included data misinterpretation and focusing only on recent policies and disregarding older policies that are still applicable. For relevance, we have 58% and 53% respectively for Georgia SNAP and Oklahoma Medicaid. And some of the errors included off-topic answers or responses with irrelevant information. For completeness, which scored really low, only at 11% and 21%, due to most responses missing key details and focusing on irrelevant administrative information rather than the general eligibility that we asked for. Finally, here we can see the graph that shows the AI-generated responses for SNAP and Medicaid across these 7 question types. For Georgia SNAP, the most variance is found in what would determine if I'm eligible category. And the highest range of values are in the summary category for Medicaid Oklahoma. It is also important to notice that none of the responses made it to 15, which was the highest score.
All right. So for experiment 3, we tested 2 approaches for generating machine-readable rules for SNAP and Medicaid using LLMs. Both approaches are using a predefined, a template of predefined rules. So the first approach relied only on the LLM's internal knowledge, and in the second approach, we aim to enhance this with a retrieval augmented generation pipeline, which would add relevant policy information to the LLM's prompt. This heat map here compares the results of both approaches across different rule categories, with blue for perfect accuracy and red for 0 accuracy. We see here that the first approach had mixed results in the different categories, struggling especially with numerical and frequently changing rules, while the RAG method, on the other hand, achieved nearly perfect accuracy, except for this one category where there was no relevant information to be retrieved from the database, which highlights the fact that while RAG improves accuracy and reduces hallucinations, its success depends heavily on the availability of high-quality and comprehensive data sets. For experiment 4, we tested 3 approaches for generating software code that would determine an applicant's worker status for Georgia SNAP. In the first approach, we just prompted the LLM to generate a Python script with very basic instructions provided. And given the limitations of this approach, we developed a set of detailed guidelines for the LLM on code structure and decision-making logic for the second approach. And for the third approach, we streamlined this process into multiple steps, first summarizing the policy, next creating pseudocode, and finally generating the actual code, where each of these steps was handled by a different LLM. So moving to the results of this experiment, and the first approach with the simple prompt obviously performed poorly in most of our evaluation criteria, rendering its output unusable, while the second approach, guided by detailed instructions, shows significant improvements in many of our evaluation criteria, including code correctness and logical consistency and overall output correctness. And surprisingly, the third approach with the iterative steps did worse than the second, where we observed that breaking down the task into smaller units introduced new challenges, such as losing key information between different stages, resulting in incomplete and non-functional code.
So what are our big takeaways? First, using AI chatbots to distill eligibility information has mixed results. Second, we found that large language models can generate machine-readable policy rules and policy code when provided policy documentation and when using detailed guidelines. And finally, we found that LLMs can be used to support rules as code adoption, but we recommend quantifying uncertainty, maintaining a human in the loop, and using databases with current policy information. Thank you.
Good afternoon. We represent the MITRE team. For those of you that don't know, MITRE is a federally funded, we operate federally funded research and development centers on behalf of the federal government. In addition to the work we do directly with federal agencies, we run an independent research and development program, which is trying to look at the next set of challenges government's going to face. What you're going to hear about today is some of the work we're doing on one of those independent research projects. Much of what you've seen today from the different demos are people looking at using AI to interact and get answers out of a huge corpus of policy information that exists. That corpus of information was written by humans for humans. It's complex, it gets amended with every piece of legislation, and some agencies, that corpus of knowledge, when you get the policy, the supporting court cases, the legislation that enumerated, memos for better understanding internally, can approach millions of pages of documentation. That's a lot of content to interact with, and it presents a lot of the challenges that we're seeing with the RAG models, the LLMs, as they try to navigate all of that. So our thought was, as we look at the federal governments that use these policies to adjudicate benefits on behalf of citizens, veterans, et cetera, we wanted to take a look at, is there a different way? Is there a way to create computable policy that becomes the source code by which LLMs interact, case management systems interact, chatbots interact? Is there a better way to communicate that knowledge? So the research we did was twofold. The first thing we wanted to do is start to take LLMs, take a look at a large corpus of policy, and start to evaluate it with metrics. As you can tell, the supply chain for how policy is created is very complicated. The resulting product, when you have different lines of business at an agency, different legal experts and policy experts writing, you get a lot of variability on this policy. And so the first area of research that we did was taking a look at LLMs and coming up with a set of metrics to help us understand readability, complexity, legal alignment. These are important things to understand the policy set you're working with. The second work stream that we took on is, once you have a corpus of policy, go down into specific policies and have the machines help us translate that into a machine-readable, computable set of code that can then be consumed by lines of business, various systems, chatbots internally, chatbots externally, et cetera. I want to make sure we stay on time here. So the most notable part about the computation or the digestion of the corpus of knowledge was thinking about the metadata. So when you have a large corpus of policy information, breaking that up and processing it so then the machines can then take the individual policy sets, the questions, the specific answers that are being asked, and translate that into the computer code. I'm going to introduce Jackie to walk us through some of our results and some of the insights that we found.
Thank you. So in terms of results to date for our research, our policy complexity analysis highlighted some interesting findings, notably the different types of relationships to other policies and legal resources. So the graph below here to the right just captures a brief snapshot of the relationship, the linkages that we found between these legislations, manuals, etc. So at first glance, the linkages appear to have more of a simple star network, but upon further analysis, we found a more complex structure. And these relationships must be interpreted for any analysis on a policy's complexity, especially as we consider the dynamic legislative landscape, timelines, and so on. But we also did a bit of work on translating a policy decision process to verifiable and executable decision model notation, or DMN rules. And as Matt alluded to, we believe that these rules are pivotal in streamlining policy implementation. So we started with a manual translation, both to understand what we would try to reproduce at a larger scale, and then to also give our LLM something to learn from. And then after verification with subject matter experts, we proceeded with the automation. An interesting outproduct of our automation work is our process to break down the step logic for making a decision as dictated by the policy rules. And a flow that we found that worked well and that we'll just continue to refine as we go forward is to take the policy, prompt the LLM to interpret its general idea or the policy decision logic, chunk this logic into more discrete steps or a decision tree, and then convert these steps into a series of connected DMN tables before finally converting it to XML for verification in our DMN simulator tool. So this flow not only got us closer to producing these computable rules, but it's also advantageous in the fact that at multiple steps in this process, a domain expert can go in and verify this translation to ensure that the LLM didn't oversimplify any rules and that all the details are appropriately captured. And then, so lastly, to evaluate our work, we generated these personae just to compare the automatically and manually generated rules. And by making this a diversity of these personae and checking where the rules differ and in their decision evaluations, we aim to stress test these rules to overcome any rare but possible edge cases and to develop intuition of how our automation can and should be improved. Insights-wise, we found that while LLMs can be used to generate the DMN notation, we still need a human to define the meta model of what decision we're actually asking of this policy text and how. So basically what questions are being asked of the policy and how must that question, as understandable as it is to a human being, be asked of an LLM in a way that makes explicit the things that we humans understand implicitly. We also found that different LLMs do have varying strengths and weaknesses, whether that's in getting the DMN syntax right or interpreting the relationship between different entities properly from the policy text. So for this, we would like to fine-tune a model for policy, and that would then be best suited for generating these rules. And then finally, like with many other projects here, we found that context is critical in translating these policies into rules. So we do need to determine a way to identify what context to include and exclude. So definitely suffice to say, a lot of interesting questions to continue to explore, but from our work so far, we're really optimistic and excited for where our project's going. So feel free to follow up with our team here at MITRE, and we'll be happy to continue the conversation. Thank you.
All right. Hi, my name's Belinda Rodriguez. I'm the product manager with mRelief.
I'm Brittany Jones. I'm the executive director here at mRelief.
Awesome. So we're here today to talk to you about how we're using generative AI to increase access to SNAP benefits. As I'm sure a lot of you are probably familiar, there's $13 billion in SNAP benefits that go unclaimed each year, meaning 7 to 8 million people who deserve benefits and are eligible for them go without. As you're also probably aware, there's a lot of reasons why people don't apply: lack of awareness, stigma, a cumbersome process, and very confusing SNAP policy. At mRelief, we have a number of solutions that help people overcome these barriers. So first, we have an ad-driven eligibility screener that helps raise awareness about SNAP and encourages clients to apply. And from there, in 9 states, clients can apply using our simplified application in 9 states that halves the number of questions and makes document submission very easy. And in another 16 states, our clients can apply over the phone with assistance from a caseworker at a community-based organization. These solutions make our clients 27% more likely to complete an application and 25% more likely to be approved. However, even with these gains, 61% of our self-service clients who start an application do not complete it. We analyzed survey responses from thousands of clients who didn't finish an application and found that there were a number of reasons why they didn't complete it, mainly having questions about their applications, such as household composition or eligibility, or needing technical support. So to address this issue, we decided to create a Gen AI chatbot that is capable of proactively reaching out to clients within minutes of starting an application, since they tend to give up within 10 to 15 minutes, and being able to answer any questions that might come up during the application process. We launched a pilot of this. Let's see, how can I get this to play? There we go. No? Yes? Oh my. Yeah, I need some AV help here. I don't know. I'm not using the mouse. Anyway, I'm just going to continue talking. We launched a pilot of this chatbot in South Carolina this month that is trained to answer general questions that clients might have about applying for SNAP, as well as South Carolina-specific policy questions. And I'm not sure if we can get this video to work, but for time's sake, I'm going to move forward. So in developing this chatbot, the first thing that we did was develop a persona to set our North Star for how we wanted this chatbot to engage with our clients. And we knew that it was very important that we wanted our chatbot to be consistently empathetic, encouraging, and clear. This persona was a very important step in our development process, so I encourage anyone to not skip this step. It definitely influenced the prompt that we developed for our chatbot, as well as the style of the content in our content library. And after having not the best success feeding the policy manual to the LLM directly or using chunking methods, we decided to take a very hands-on approach to developing a comprehensive content library. We started with thousands of responses, survey responses from clients who didn't apply, and created a content library that was pretty much prepared to address any issue that had prevented a client from applying in the past. We got our client support advocate and our policy expert involved in the creation of this content. That was really crucial, as well as performing ongoing evaluation to make sure that any changes didn't have unintended consequences. And with this combined approach today, 90% of the responses from the chatbot are helpful and accurate according to human evaluation. I mentioned that the content creation was really important, and I just wanted to highlight a little bit about how we went about that, because this was one of our major learnings. We initially developed our content library to be structured based on questions and answers, but we noticed there were some problems there. It was easy for the chatbot to get confused if questions were worded too similarly, and made it more likely that the chatbot might hallucinate as a result. So instead, we structured it based on intents. So we, in terms of what that process looked like, we started with survey responses for clients who hadn't completed an application in the past. In this example, the person said they didn't finish because they messed up the application. So then we turned that into an intent, which is, okay, the client wants to update information on the food stamp application or correct a mistake. That is their intent, and there could be a number of ways that a client might express the same intent with different language. From there, we created a canned response that we think is ideal for this intent, and we're also able to include examples of different ways a client might ask a question that might get at the same intent, so the chatbot is more likely to correctly identify similar use cases. In terms of what's coming next, we would like to scale capacity for evaluation. It's currently all manual. We want to train our chatbot to be able to offer assistance in Spanish, and these two things are going to prepare us to scale the chatbot to additional states. When it's fully scaled to all of our states where we offer a self-service application, we'll be able to offer proactive assistance to 100,000 clients in the first year. This is 10 times our current capacity to offer support to clients with our one full-time client advocate. And if it's scaled to our states where we have our screener-only experience, we'd be able to offer assistance to over 340,000 clients who are applying for SNAP. And with that, thanks so much for your time, and please talk to us if you have any more questions.
Hello. I'll give it a minute, hopefully get the slides back up. but I'll introduce myself first. My name is Ryan, and my colleague Kevin is joining me, and we are from NAVA, and we will be talking about our assistive chatbot for benefit navigators. Please hold. To be specific, I think we need to go back to the other slide deck. There we are. Thank you. Okay, so to move on, we are designing this assistive chatbot tool for benefit navigators, and some people have mentioned that term already, but for our project, this person could take on a number of different roles. They might be called a contact center agent, a caseworker, outreach staff. They might work on a single program like Snap Outreach over the phone, or they might work in, say, Los Angeles County and help clients navigate all of the programs in that geographic area. And so they work with families to screen, apply, use, and keep benefits. So a very wide range of tasks, even if they're only working on one program. And even if you're only working on one program, questions about others might come up while you're talking to a family. So like I said, our tool is a RAG, retrieval augmented generation assistive chatbot. And the opportunity here is really about lowering the cognitive burden that you need in order to navigate all those programs, especially when you're in the moment, either on the phone or speaking to someone across the table. So the AI solution there is, again, the chatbot to go through those rules, provide plain language responses, and our kind of flavor is really exploring the idea of citations. So if you want to look up more, how do you give people the ability to verify the response? Quick overview, it looks similar to a lot of different chatbots. You have a prompt, you have a response. I'll just point out that we are shaping this with benefit navigators. So what is the format? How is it responding? What terminology to use, not use? And then the citation below here, which could come from a number of different knowledge sources. A quick quote here to kind of put it in context again, and this is from a contact center-based navigator, all about the need for in-the-moment information. If you don't provide that, people are just going to walk away and they have to deal with the rest of their life. So I'm going to pass it to Kevin to go through the tool and how it's actually used.
Awesome. Thanks, Ryan. So I'm going to really quickly go through 3 questions here. The first is someone asking a question about how the child tax credit interacts with SNAP. And after sifting through some policy documentation for a few seconds, our chatbot's going to give an answer. But what you'll also see is that we spent quite a bit of screen real estate on getting references to the underlying documentation sources so that someone can click in and see an exact quote that the AI is drawing on to produce that answer. So that's not AI generated, that's pulled from the underlying documentation. And the reason that's so important is because we want to empower the navigators that are using this tool to be able to assess whether or not they should be confident in the answer they're getting from this tool. So here's an example of why that matters. Here's the same question, but actually about earned income tax credit. There's an AI-generated answer there, but more importantly, before we took this screenshot, we actually deleted any references to EITC out of the underlying documentation. So the chatbot here is just winging it. And you can tell that really easily because when you look at the source it's citing, that's not EITC, that's CTC. So a user seeing this can quickly see, I'm not sure I should actually be using the LLM in this particular situation. Let me fall back on asking a colleague or some other source here. And we also want to provide them an opportunity to flag that, not just for us as the development team. We're an agile team. We love getting this kind of feedback because it's an opportunity for us to iterate on the chatbot. But actually, even more valuable, this chatbot is drawing on documentation written by humans, and humans are the primary audience for it. If the documentation is missing something like a reference to EITC and how that interacts with SNAP, that's actually an opportunity to go improve the underlying documentation so that it's better not just for people who are using the chatbot and for the chatbot itself, but for other users of the documentation, whether they care about using this particular tool at all. So hopefully it starts to kick off a virtuous cycle of when the chatbot can't answer something using the documentation, the team is alerted, and folks can then go and improve the underlying documentation and make that better too. All right, so far we've been looking at answers generated from a documentation source set that followed an FAQ format. So here's a common question about policy that navigators often have. Here's an answer for it. We can also start to digest and make more accessible very large, formal, structured policy. So Lynn mentioned earlier bookshelves being turned into PDFs. This is a great example of that. There's about 130 PDFs in this data set of various lengths. They actually are pretty well structured, decent plain language throughout, and we can take those, digest them into the chatbot, and then when users have questions about them, we can generate an answer based on this documentation, but we can also make it very easy to go in and see the specific subsection, see the direct quote from the documentation that answers the question, and then even do deep links in so that someone can go in, view the underlying PDF, and be able to see the context above and below, perhaps.
All right, to wrap it up for today, we are developing our evaluation approach with each new iteration of the tool. This is just a screenshot of our human evaluation template that we're using now, which I will just lay as a teaser for what's next for us, which is that we are very excited to actually try this out with a community-based organization and navigation partner. And so to do that, we will set up the bot for multiple programs in a single geographic area. And while we're going, setting up advisory boards of clients, navigators, and subject matter experts to help us improve the tool as we go, as well as those feedback methods Kevin mentioned. Luckily, this is a Bill and Melinda Gates funded project, so we are able to share most everything we do. There's a link there, and also in the Airtable that will be provided later. So thank you.
Thanks. I'm Max from Policy Engine, and my colleague Lee couldn't make it here, but presenting work from the two of us, as well as a number of our other colleagues at Policy Engine, on how to make benefit eligibility determinations more understandable with AI. So Policy Engine is an open source software platform for tax and benefit policy analysis and benefit access. So our users can estimate their taxes and benefits by plugging in some information about themselves, either into our own web app or our API partners, My Friend Ben and Social Benefit Navigator. They can also design custom policy reforms and see how those would affect outcomes like poverty and inequality. Underlying all of this is an open source tax benefit rules as code engine. Now, our users often ask questions like, why is my household eligible or ineligible for some benefit? Or where did these numbers come from? Or how would this change if my household situation were to change? And these are pretty complicated questions to answer because there's a lot of interdependencies between different programs. Each individual program has thresholds, phase-outs, phase-ins. They depend on lots of different household characteristics. So when this question has come up, we've used some Python tooling, which enables us to basically generate a big text document that looks through what we call the computation tree. So for a given household, if you're trying to estimate, for example, what their SSI benefit is, you can look through this thing. It looks like the matrix on the right, or yeah, you're right, and see, okay, you're getting, what is it, 1602, that's dependent on the maximum of 10092, and then you have some earnings and a bunch of income that gets deemed. So you can learn to use this. It's quite flexible, but it's not super interpretable. So our thought was, can we use AI to summarize the information from this computation tree we already have at our disposal? And the way we started with this was building a Streamlit app. So this is a great tool for prototyping with Python, building a dashboard where you can plug in information about household and the variable you're interested in. And we just take that tree and send it to a Claude 3.5 Sonnet API request, ask it to summarize it, and you get information like what's on the right here. So the result of 5176 is this household SNAP benefit, and that's because they get a maximum allotment of $766 a month for the first 9 months. It changes in October. There's some expected contribution, and it tells you some other information. And this is all coming from our rules engine, so it's not sort of making stuff up. There's not really room for it to do that. So it worked pretty well. So we decided to put it into the product, which we're finalizing now. And essentially, we're tracking the computation tree in our database and surfacing a new API endpoint that uses the Claude 3.5 Sonnet API, plus that new information, and we display it to the user. So let me show you how it works. This is policyengine.org, where you can select compute my taxes and benefits, plug in information about your household. We start with just 6 questions to get the user started. You can always add more detail from there, such as childcare expenses, housing costs, disability status. But basically, marital status, number of kids, where you live, your earnings, and your age. Those are enough for us to estimate a wide range of different programs: SNAP, EITC, state-level tax credits, SSI. And so it's now computing all of that. And we get to the set of programs. You can see your benefits, total refundable tax credits, and your taxes. And once you get into, for example, the EITC, that's going to be the federal earned income credit, 6960. This is the new feature we've added. So it's now grabbing information from the LLM prompt that's coming from the computation tree, telling the user, okay, you're getting that much because that's the maximum amount for the EITC for a household like yours, and you've earned enough so that you're no longer in the phase-in range, but you haven't earned so much you're in the phase-out range. So we've tested it with a wide range of cases across households and programs, and actually there are no errors. So I think this speaks to, first of all, Claude 3.5 Sonnet is just an amazing LLM, and also we're not giving it room. We're giving it a lot of detailed information that's enough for it to work with. In terms of where we're going next, we've already found it useful internally. When we get questions like these from our users, we can quickly debug and figure out what's going on. We think there's opportunity to clarify what the results are. So even though there aren't errors, there are some opportunities to give some more clear information by maybe going deeper into the tree, providing some extra information into the prompt. But basically, it's enough for us to really believe this could be a great feature for bringing into our API customers to help them get people across the finish line, really give them confidence in the results that we're providing so that they can complete their application. And also to educate case managers and policymakers about the complexities and nuance of these rules. So we're really grateful we had the summer to explore using the best of rules as code, combining with AI to democratize access to high-quality, personalized calculations around benefit information. So with that, I will turn it over to the ragtag snappers. Thanks.
Hi, everyone. I'm Sophie.
And I'm Evelyn, and together with our teammate Ellie, we are the Ragtag Snappers. Before we get started, we want to send a huge, huge thank you to our mentor, Michael, without whom this project would not have been possible. Okay, so our project really focused on how could we use something like Policy2Code to improve payment accuracy in DC by aiding SNAP caseworkers. And so we all know SNAP caseworkers work really, really hard, and with 1 in 5 DC residents eligible for SNAP and less than 1 year to ramp up new SNAP caseworkers, it's a very difficult job. And we kind of put them in a difficult situation where only 48% of all applications can even be completed by the federal timeliness mandate. And sometimes we put them in situations where they just have minutes to review really complex cases before they head into the application interview. So Michael pointed out, perhaps this is a really good use case where we can use the over 40,000 existing DC data points to try to build a model to improve this process. So for those of you who aren't familiar, the SNAP case review process kind of has 4 main steps. So the first is that an application form is submitted. A caseworker and an eligibility system currently processes that application, and then the same or a different caseworker then interviews the household. And then all that information combined is finally used to determine SNAP eligibility. So the first question we asked was, can we use Policy2Code to process SNAP applications accurately? And so we thought, let's shoot for the moon. Let's see if an LLM could do this entire gray box by itself. Then the second, possibly more practical question that we ask is, how can we use an AI to assist the entire process to make it more efficient? And so Michael helped us identify several different ways that we could consider exploring the impact of an LLM. So for example, in the first step, when an application form is submitted, perhaps we could use an LLM to create a more readable text synthesis that someone could ingest more holistically. Or we could potentially ask an LLM to review the text application to identify inconsistencies that are commonly already identified by the SNAP QC data for the caseworker to follow up with during the interview. And then during the interview, now there's live transcriptions, so could you use that to kind of live identify inconsistencies during the interview that you can clarify with the application, and then ask them to update the application so when the final case assessment is made, you're able to kind of get the most accurate assessment of benefits that you can. So what did we do? To answer the first question, we built a RAG model using GPT-4o Mini, as many people here did. We used the model to calculate benefits for kind of all 259 applications that exist in the SNAP QC 2022 data. And then we used that DC data to then compare our model outputs to see how our model performed. And then separately, to kind of see if we can use LLMs to identify SNAP application inconsistencies, we tested off-the-shelf ChatGPT interface to see if there was anything that it could possibly do that people can just easily grab today. And so this video is a demo of us doing just that.
It does have sound. Is it possible to...
Do you want to talk over it?
Okay, I'll talk over it. So this is a case file that was just an example case file here, and we wanted to test out just getting a quick summary from what can be like 15 pages of case notes that the caseworker needs to review before an interview. So it just gives a really quick overview that they can then go into the interview with to ask relevant questions to the customer. Our next experiment was uploading common SNAP errors that we found in that QC data, as well as a mock SNAP application that we intentionally had errors in to see if it could compare those and identify those errors in that document. And it is able to actually identify that, give us sort of a bulleted list of what those errors might be. And so then the caseworker is really armed with that information to go into the interview and clarify those points with the customer. And this makes it really efficient, so they're not trying to go through the entire application themselves, but they can kind of identify those errors that we already know about pre-interview. And then the last thing that we did was just get that live transcription that Evelyn was talking about and be able to compare, the things that came up in the interview that did clarify the errors that we identified in the previous step and be able to follow up after the interview to say like, okay, we identified these errors, then we got clarification during the interview, we can verify that with the transcript. Now what are the follow-up steps? What are the ways in which you need to address in your application the errors that we've identified from there? So these again are just using the off-the-shelf models to identify just a few quick areas that can help caseworkers. Nothing revolutionary, but just seeing how this can already be leveraged with what's already widely available.
Great. So what did we learn? So as a high-level summary across kind of all the use cases that we explored, LLMs are good at reading and synthesizing text, but really not good at following strict formulas. And something like calculating SNAP eligibility and final amount is a strict formula. And this is really not surprising because this is exactly what LLMs are built to do. So what we found is like when we fed it the SNAP regulations, it was generally correctly interpreting the rules about SNAP. And importantly, it was really good at simplifying the policy language into something that was really easy to understand. understand. When we asked it to kind of explain how it was calculating the SNAP results, it was able to kind of tell us what it was doing in a fairly logical manner, and actually made it quite easy to troubleshoot because you could clearly say, it's doing this wrong, it's doing this wrong. And then as you saw with the video, it was really good at summarizing long case notes into something that someone could easily digest. What it was not good at is it was very bad at interpreting vague words. So something like shelter cost, it is actually only supposed to include rent, but the LLM said that it was rent and utilities. And something like this is very important to flag because precision in these numbers is important to reduce errors. And then finally, LLMs, again, are bad at math. It did not subtract deductions in the right order. So basically, we found all of the calculated benefits were wrong. So in conclusion, you should not use LLMs to follow a strict formula like benefit calculation, but it's great at summarizing text. It's not going to replace subject matter expertise, but we can find interesting ways to use their strength in general tests to speed up the eligibility process. And then just as a summary, we color-coded kind of how we think LLMs can really contribute to each of these different steps. The orange here is where we felt LLMs were really good, but you still had to kind of manually update and tell it in a specific prompt what you wanted to do. And that's all.
Thank you. Hi, everyone. Okay, we are team Palms and Circumstance, which is a pun if you know about SSI. We're presenting our work on SSI non-citizen eligibility. I'm Nicholas Burka. I work on disability benefits access in New York, and this is my colleague Yuan.
Yeah, you can also call me David. I'm a member of Civics Tech Toronto. I'm now a full-time job hunter, so if you saw a job in the wild, don't panic. Just call me. It's my honor to be here today.
Yeah, we came together kind of serendipitously. I found out about this challenge just before it closed, and met Yuan and another person looking for teams, as well as, very fortunately, Mark Raifman, who is a disability benefits attorney. So it was a really perfect complement of skills. I'm kind of in between them in the legal tech world. Yuan is quite a skilled AI engineer, and Mark Raifman is, of course, the attorney. We also got a lot of help from the Policy Engine team, as well as Louise Pocock, and some other Policy2Code community members. Thank you. It was invaluable for our work. So we had two main motivations coming into this challenge. One was to make a general purpose SSI eligibility information tool, like a chatbot. And the second was to combine rules as code approaches with LLMs. So first we wanted to pick our rules as code engine, and we went with Policy Engine because it is so widely used and it is open source and it has all of those nice ethics that we feel aligned with. And it already had income-based rules for SSI eligibility, but didn't yet have immigration status-based rules for SSI eligibility. So this was, for us, a great potential impact opportunity to combine with our learning opportunity. We used Cloud 3.5 as our LLM system, and Yuan tested it in 4 different ways, which we'll tell you about in a moment. Before we get into that, I'll talk a little bit about our approach to generating Policy Engine code. So basically, it was pretty simple. We fed a bunch of Policy Engine examples along with a section of the POMS, which is the document that outlines eligibility for SSI. Into Cloud 3.5, we use their project feature, which allows you to feed in a bunch of different documents. That generated a pretty strong initial set of code files for Policy Engine, which we then fed in. I fed this into the Cursor IDE, which is a kind of AI-informed way to develop code. And this ended up with some pretty solid skeleton code that we were able to make a pull request for and begin to merge it into Policy Engine's code base. But again, as other teams have mentioned, this was no replacement for human expertise, both on the legal and technical side. Also, the code that it generated was relatively basic in terms of capturing the nuances of these non-citizen eligibility rules, but we thought was a good enough first step to potentially merge into that code base.
Thank you. So we tested the LLM Clause 3.5 with 4 different ways to answer the SSI question directly instead of we try to skip the policy engine. And this is naive RNG we have tested. It's very naive. Like if you ask me a question about SSI, I have no idea. So all I do is go Google and tell you what I found in Google. So that's naive RNG. Search in those PDFs just like searching in Google. And Nick, he is good at Googling. So he will do, like before searching, he will do refine of the keywords, so he can get a better result, search result. And also after searching the keywords, he will refine, like reading the findings and then close the irrelevant tabs and then refine the keyword to search again. So that's the advanced RAG. And the limitation of RAG, like you're reading a book like this, all right? Blah, blah, blah. Okay, we have Luke, blah, blah, blah. Oh, Anakin, blah, blah, blah. Darth Vader, blah, blah, blah. Ben. Okay, now question. What's the relationship between Darth Vader and Luke, or Darth Vader and Ben? If you search, like RAG, find nothing. So the answer, I don't know. Oh, no! No. But don't worry, we got you covered. Adding the graph database, it captures the relationship information in the documents. And then it's the only cases in our tests that is able to discuss the citations from the 1996 law and DACA for the undocumented personnel. And we try to replace the graph database to using a program like Prolog. What we do is to generate code from the documents into Prologs, which we have mentioned the details in the Slack, and then the LM will generate reading the question and then read the information about the existing code to generate a code to execute with the code library, and then getting a result. And then finally, the LM will read the result and also retrieval from the original document to generate a final result. The RAG we use in refining the final result is the naive RAG we've mentioned before, and the generation of the code library is just using prompts and iteratively generated. Yep, the detail is mentioned in the Slack, so maybe if you are interested, we can discuss later. And then the results of our testings. We test the all options using a set of yes or no questions here. The policy engine is about able to produce a result for around 45% of the question, but getting 100% accuracy. It requires some human labor work to cover the rest of the test cases, while the LM was able to cover all the test cases and but getting around 92% accuracies. The best performance is by the advanced RAG, which we use the PaperQA implementations.
Oh yeah. I have a mic in my hand. Yes, and one other thing to note was a lot of the LLM cases, you can't really differentiate on score alone. You kind of have to go in and see the nuance of those different answers. So we produced some nice artifacts during our work. One is the actual policy engine code, which we're currently working on editing and hoping to merge soon after we complete those edits. And then we also have the validation set we use to test our LLMs. So these are 10 expert-generated user personas for benchmarking SSI eligibility that Mark Raifman came up with, as well as 100 LLM-generated true or false questions that we reviewed ourselves to the best of our knowledge using those policy documents. So those are available here at this link. And for our next steps, we want to refine this work and see if we can get towards something that could be internally facing and then eventually public facing in doing SSI and SSDI eligibility determinations. And we also want to work on bringing together these rules as code and LLM systems, probably in a way that's going to leverage your work in Policy Engine that you just presented. We also had this idea that thought it would be interesting to bring in decision model notation, as the MITRE team had, to Policy Engine in some way. I mean, that's a huge, ambitious idea, but it was just kind of an interesting thought. And to expand the eligibility rules that we cover with our system into the medical eligibility rules that come after that pre-medical step, helping people understand how their medical condition and the way that their disability works fits into how the Social Security Administration considers it. Oops. Okay. Yeah, thank you all so much. And if you're interested in disability benefits access, please talk to us. Thank you.
Wait, which button did you push to turn that off? I don't want to push that.
It was that.
I'm not touching it.
Just leave it up there.
Hello? My name is Mark Head. This is my colleague Deirdre. We are from a company called Ad Hoc. We build modern user-centered digital services for federal agencies and state governments. And as part of that work, we have come to find, this will surprise you, that converting complex rules in public policies into code is hard. It's costly, it's error-prone, mistakes happen. And one of the primary reasons for that is because the two groups of people who are involved in implementing digital systems are experts in different things. The policy subject matter experts, or SMEs, are experts in the policy and the context around that policy. We've seen a lot of legal documents up on this screen today, right? There's a lot of context around these policies. And software engineers, people that understand technology and how to write code and how to set up cloud infrastructure. So we took a little bit of a different approach than some of the teams. Our goal was not to apply large language models toward the sharp end of the stick where the benefits are being administered or questions are being asked, but more earlier in the cycle, so to speak. We wanted to find a way to use large language models to make policy SMEs, policy subject matter experts, the people that are better able to determine whether or not a system has been implemented correctly. So the approach that we came to as we started to work on this was using LLMs in a workflow where a policy is described in a domain-specific language program. This program has features that will help ensure accuracy and completeness, and our goal was to position SMEs, policy SMEs, as the correct arbiters of whether or not a system has been implemented properly. Empowering SMEs, that's what we're about. Like a lot of the other teams, we used Claude 3.5, and we also used the Medicare prescription payment program policy from CMS. That was the right one, right? Okay, just making sure. We wanted to determine a few things. One, like many other teams, we wanted to determine how well a current generation LLM could produce valid DSL code directly from a policy document. Because we didn't have access to policy SMEs at federal agencies, we wanted to use other folks that we had more access to help us verify what we were targeting. Our ultimate goal is to show those folks, to show policy SMEs in government the value of this approach and that they can use these tools, not unlike software developers and other people are starting to use LLMs. There was all this discussion when LLMs hit the scene that they were going to displace white-collar workers, they were going to replace software developers, and now we're finding out through a lot of current research that's not true. Software developers and other people are using LLMs as productivity tools. When they're used properly, they can help software developers and others do their jobs better, and we believe that policy SMEs are in a similar situation. Deirdre?
All right. So you heard Mark mention DSLs. Oh, well, I thought this guy was picking it up.
I don't think this one works. I think it's either that.
Oh, okay. All right. It's on. Go ahead.
Should be on.
On? Yeah. Okay. So you heard Mark mention DSLs, domain-specific languages. So the approach that we were really focusing on was, could we come up with a DSL that would be useful to policy subject matter experts, and could we get an LLM to actually generate valid code in a language that it hadn't seen before? So in order to do that, there were a few things that we needed to be sure that LLMs could do. They had to be able to generate code in a known language from policy. They had to be conformant to the grammar. They had to be able to fix mistakes that you pointed out to it, and it needed to be able to document its output, because you've seen in some of the other examples, being able to cite the particular regulation that you're implementing is really important to subject matter experts. Next, where's the click? Okay, so what we're showing you here is we're looking at our first experiment that we did to try and prove this point that, yes, Claude could actually take a policy document, it could turn it into valid code, and we could turn it into valid code. The valid code is there on the left, your right. It's generating Go code here. The Go code was syntactically correct. It compiled and it produced a valid result. So that was a yes. So that was one of our first experiments, and then it was, I'm sorry?
Go to the next one?
Yeah. So once we proved that point, we moved on to the next one. We said, okay, can we actually get the LLM to understand our DSL? So in this experiment, we fed it the grammar, we fed it an input document, we fed it a somewhat detailed prompt that you can see up there, and then we generated the code. And here what it's done is it's produced code that's valid in our DSL. It is syntactically correct. It's using keywords in the language that we know are in the language and are not in general languages, so we know it's using the grammar. And what it has done is it has taken the policy, it's summarized all of the data structures in it, it's summarized the rules, and it's summarized the relationships, the rules that establish relationships between the different data types that are in the policy, that are in the DSL program that it generated. So, next slide. So what we found, we can actually use a defined grammar. The LLM can actually, this particular LLM, Claude, was able to interpret grammars, it was able to write grammars, it was able to edit grammars. So that really surprised me. I really did not expect that, but that was an important part of the investigation that we did, because if it didn't have a concept of how computer language grammars work, it wasn't going to be able to do the kind of interpretation that we needed it to do. So that was a really key finding. Another key finding is that, that it was really sensitive to the input grammar and the amount of ambiguity in the input grammar. So input grammars need to be fairly tuned to work well, to work with the LLM that they are...
Don't download that.
To work with the LLM that they're intended to work with, it seems. The other thing is... well, let's see, it's not up there. You've heard this a lot. You need to validate what that LLM is doing. You can't trust it out the door. You may know that it's generating valid grammar, but you have to check to make sure that it's actually picking up all of the pieces of the policy that it actually needs to pick up, and that it hasn't missed something that you needed to. The nice thing is you can say, hey, you forgot this. Would you please go add it back in? And it will do that perfectly happy. At least Claude will. One of the things that we're doing is we're looking at building validations into both the tool set and the language itself, so that you're getting it in both places. And
to me, one of the most important findings is we can use LLMs as part of a tool chain. We can enable policy SMEs to be better arbiters of correctness in a system. What are we going to do next? Well, we're going to include some actual government policy SMEs. In the next phase of work, we're going to further develop our grammar. We're going to widen our sample of policy documents. We want to see how this works with a whole range of policy documents. And we're going to continue to refine our DSL validators. So onward to more empowered SMEs. Thank you.
Yeah, almost the last one. We are from the Tech2I company, and our company been assisting CMS in the health insurance marketplace work for more than a decade, and that's why we as many of you have a good experience with working with the challenges, and we see so that how it's difficult for people to get the right information, to know all the options so that are available on the market, and navigating all these ever-changing rules and policies. It's really difficult. So this is one of the main challenges that we were trying to address in this solution. And I would say so that in more detailed bullets, so that we kind of tried to put on this slide, is that the rules are changing from state to state. Besides the differences in rules from state to state, so like we also have different programs. Sometimes people don't know if they're eligible for Medicaid, for CHIP, for private insurance, where do we go? So like the websites are different, and so people are just lost in this maze of options, and so that they may not know so like where to go. And another problem that we see is that in my home state, which is Virginia, we have nearly 2 million people that rely on Medicaid and CHIP, and we have. It's estimated so like that so there's only one navigator per 40,000 people. It's just not enough, and it will never be enough. And in 2024, the government is set to spend about 100 million for the public assistance programs, basically so for the navigators, so that are assisting people, and it will never be enough. And that's why so the question is it possible to build something that will solve this problem, so like, and will make the information available and reliable. And finally, so like if we are using the GenAI to solve this problem, can we trust it? So that's the problem statement, so that we kind of identify it. So again, I'll pass it to my colleague Harsh to continue with the next slide.
So let's talk about the research methodology. So our research methodology focused on
integrating generative AI into data analytic workflows. And we leveraged large learning models to streamline the processes without needing a deep dive in data science itself. We selected the right tools to build a functional application using LLM APIs. We also addressed LLM limitations, such as hallucinations and outdated data, by implementing a selective input process and using human-machine collaboration. The LLM acted as a search engine, while human experts curated and validated the information. Lastly, we experimented with various LLMs and prompt engineering, optimizing performance for the policy's needs. Our target audience, we kind of would like to focus on low-income families and vulnerable populations, simplifying eligibility assessments for quicker access to Medicaid and CHIP. Administrators can also use AI chatbots to streamline this process, improving efficiency and ensuring accurate information for applicants. And we have a demo here. Hopefully that works in my not greatest voice. There we go. I don't know if the volume is there. Oh. Sorry, this is a technical issue. Yeah, I guess not. Anyways, I'll talk over it. So we have an admin side of the application where we kind of have 50 states on the left side, including a federal tab on the left. And then we have a fetch data sources tab on the top right. So in the fetch data sources, when we click that, we get all the links and data sources that are related to that particular state for Medicaid or CHIP. And then we can edit these links, look at these links, and change it accordingly. And this is what the admin would be doing. And then the admin can save these links, create summaries, and these summaries also have prompts that are editable by the admin. And then the summaries can also be changed as per what the admin feels is necessary. And these are experts in the field. And also questions are created using the summaries that we had. And these questions are also editable. And these are the questions that's going to be used to determine eligibility for any of the users that are using our chatbot. There's a federal tab. I kind of missed that. But in the federal tab, we also have any federal guidelines that are relevant in CHIP and Medicaid. And those federal guidelines kind of help the chatbot understand the MAGI and AGI kind of rules. They follow the same pattern of what was being done in the states. Also, in that demo, we showed more for the CHIP, but we also have a button that can go into Medicaid, so we can flip into both programs. And also, we have the chatbot here, and then basically asks a bunch of questions, and then the user will get to know if he or she qualifies for CHIP or Medicaid. From the admin side, another very important aspect to note is that part of the application will not be used on a regular day-to-day basis, but rather for policy changes or during any data that has not been inputted correctly. So that's a barrier that we are creating to make sure that we don't have any false information going to applicants. So for our key findings, AI is powerful, but human oversight is essential to avoid risks like inaccuracies and hallucinations. Just like Tesla's autopilot, where drivers keep their hands on the steering wheel, Gen AI works best with human collaboration and ongoing iterations to ensure safety and accuracy. AI-driven summarization and question generation can simplify access to Medicaid and CHIP benefits, making eligibility assessments easier. Beyond Medicaid, this approach can be applied to other government services and healthcare programs, improving public access and reducing administrative burden and costs.
I would like to also clarify so that so what we call admin is actually a subject matter expert, and the subject matter expert so has the opportunity to review the results before so they are going public. So essentially, so like if I need to ask these questions to determine the eligibility, then the subject matter expert, which is the admin in our case, so can do it beforehand. So like and then after so this is prepared, so only then so like this application will the chatbot so will actually so like ask these questions. So that's what we call admin. In essence, it's similar to what the other teams so also did. It's the collaboration between the human and the Gen AI. So that's what it is. And next steps. So essentially, so like we have maybe too many bullets here. So but let me just summarize this way. So like we want to make this collaboration between the generative AI and human a practical solution. So we want to make it a really helpful and useful framework that can be applied to different so public policies. And while doing this, we also need to make sure so that the personal data, so privacy is actually so handled the right way. So it should be hardened solution. So like the data should not be leaking. So like and should not be traveling too far. So like we also need to make sure so that the results are 100% accurate. So for this, so like we generated automatically so like the prologue code, and so like the results were pretty good. And we believe so that the prologue can be used as a tool for data quality metrics, and also to so basically so we can use this as a way to test if our results are correct or not. And another thing so like that we are hoping to achieve is to work with regulators and maybe recommend the more standardized way that is easy to understand for both humans and the LLMs. And this way, so like it will be much easier so for technology side to produce the tools like calculators that will calculate the cost and other aspects of this of the policies. So that's our next steps, and with this we're almost done.
Yeah.
So,
yeah. The only last thing is on the.
Sorry. So like this is just the technology that we explored. So that's all. Thank you very much. So like.
We hear you, Maddie. A little echoey.
All right, I'll go ahead. If it gets too echoey, tell me to stop. I actually need to turn my volume down because I hear echo too. Should I keep going? Should I stop? I'll keep going. All right, my name is Maddie Rogers. I'm the Director of Civic Innovation for the City of South Bend, Indiana. Within my portfolio of civic innovation, we do have a vertical that is focused on increasing the enrollment in all of our social benefit programs. For the purpose of this particular project, we were focusing on increasing enrollment for two particular benefit enrollment programs. One of those is LIHEAP, that stands for the Low Income Household Energy Assistance Program, and then the Utility Assistance Program, or UAP. LIHEAP is, for those of you who are familiar, it is a federally ran program that provides a lump sum to eligible low-income households to help pay for energy bills, not necessarily water bills. Utility Assistance Program is a locally controlled program by the city of South Bend that helps to pay for low-income households' water bills. The UAP enrollment process is very, very easy. We don't require any proof of income upon application. We do run audits regularly through the program. But for somebody to apply to the program, you just fill out a really quick form online or over the phone in order to enroll. For LIHEAP, for those who are familiar, the process for applying is very arduous. It requires a lot of documentation, a lot of proof of income. We often, when we sit down to help residents apply for these social benefit programs, will apply for both LIHEAP and UAP at the same time because eligibility is often cross-functional. What I set out to do with Trina here is to try to improve the uptake of these enrollment programs because we do sit down with residents and apply for both, one of them being a very easy process, but one of them being a very difficult process. Inserting an additional method of assistance could be really helpful to help people understand what programs or what paperwork is required for the LIHEAP and what can be translated over to UAP. So after setting that stage, I'll pass it to Sri to talk about.
Awesome. Thanks, Maggie. And just to kind of dive into sort of what we ended up working on, we had an initial plan of actually trying to build our chatbots that are trained using RAG on a variety of documents. And the two interesting things that we were focused on, useful for a lot of folks in this college, is we used both raw training material from the government for LIHEAP and also training material that's prepared by the City of South Bend team for training their own assisters. And so you kind of see an example, like, what does the LIHEAP concept look like? You end up seeing the sources, and quite often, and they've got qualitative analysis, we're doing it in a more rigorous way. We found that the trained materials are much more succinct and able to yield better answers and the quality of answers we're able to generate for the benefits assisters or even the end users as compared to the raw policy document. And we built like a lightweight scoring method to validate how to kind of get the answers for what this looks like. Now, we're still obviously doing a lot more testing, and right now, obviously, this is like the raw internal version of this, but we're working towards learning how to get to better understanding of what particular questions and what documents are the most useful, and then shrinking the universe of documents, which is something we've heard and throughout today, on which sets of documents are actually most useful and how do we reduce the default problem. Then we go to the next slide. I think some of the documents, I think we mentioned, the quality can vary. One of the things we look for, and I said this is probably like a holy grail that was hard to get to, was actual administrative feedback. We were looking for applicants who got rejected or the questions that are being handled by the decision makers for a program like LIHEAP, which is often like in Indiana, civic institutions that are nonprofits are administering it, and it's quite hard to get access to it, but would be pretty helpful. The other thing useful for a lot of folks in this call is we're trying to do some of the off-the-shelf assistant APIs of document. We found it hard to get documents coding working, and so we ended up using our own scoring method to be able to get the score development for each document thanks to some great folks on our team. I think the other thing that we're working on is obviously feedback on the quality of answers, both with experts and then with enrollment specialists, for probably more on the City of South Bend side, and also a bit more like quantitative analysis of the results and the quality of the responses, and scoring them. And I think there's more work to be done there. So go to the next slide. I think the immediate plan, and I think here Maggie can jump in and talk a little bit where we're thinking about where this could play out in terms of where we might start using this in the immediate future.
Yeah, so although Sri showed that the chatbot may seem more internal, and we're really excited to be able to test it here in the coming few weeks. We are about to do an enrollment push with what we call sign-up-a-thon. We're going to train local community-based organizations who may or may not be in the social assistance space to train the trainer with some of their lead navigators and invite their constituents into a room, put a bunch of computers around the room, and have people sign up for these programs. Now, because the participants will likely outnumber the actual navigators, having something like this chatbot along with each computer would really, really assist the individuals as they're applying. If they have any quick questions that a navigator won't be able to answer, they have questions about which program do I need what documentation for, where does this income go, that's where this chatbot can step in. So that's something that is very near for a test of what this chatbot can do.
And then just more broad strokes, just talk about where we can also expand beyond that. I think we're thinking about some models for all regions. Starlight, which partner with City of South Bend, works on benefit access for financial institutions and using the transaction data that people qualify residents for what program we can get. So we're looking a lot into how we can use pre-existing financial data with the consent of the resident to help them find what programs they're qualified for. And so this sliding example is like one prototype of what like a longer-term model could look like for various benefits in each region, and where we inform people long before they even walked in and said they need help about what programs they're qualified for, how to apply it, and how to guide them through the process. But thanks a lot. It's a really interesting group of projects. Thanks for listening.
Don't want to hear myself that many times over, actually. So let's get another round of applause for these amazing demos from these teams. This is months and months of research packed into 5-ish minutes, and is really no small feat to actually do that, and so super proud of all of you.
What a range, right?
Yes, and what an incredible range of policies, technologies, different skills coming together, really incredible. So one last plug for our Community Choice Award. So let's get that code scanned if you haven't scanned it, and remember which team was your favorite. And then we are going to dive into the awards selected by our organizers. I'm going to invite teams to come up. There's multiple teams per every award category. When you come up with your team, you're going to come to the center. Michaela is going to hand you this fun sign. You're going to get your team photo with the photographer, and then you're going to go see Angelica and Meg down at the end, who are going to give you your certificate that you got to take home. While we're doing one last plug on Community Choice Award, I did want to thank, again, our amazing coaches who have just been wonderful mentors. They've participated in every touch point throughout the summer, and many, many side meetings, Slack chats, emails, helping people tune their slides. So a huge thank you to Harold Moore, who's my colleague at the Beeck Center, Meg Young, who's here with us from Data and Society, Andrew Gamino Chong, and Michael Rebar from WeStat. So thank you so, so much to the coaches. We really appreciate you. All right, should we dive in?
Yeah, we should. Let's do it.
We're skipping Q&A. All right, so first up, for outstanding policy impact, these teams explored a unique policy use case that could advance how policies are communicated and utilized in the future. First up are our Canadian colleagues, BDO Policy Pulse. Next up in the same category is going to be the MITRE team.
I feel like everyone should stand.
Yeah, I feel like maybe we should stand and then we can easily move.
Yeah.
And also Team Impromptu.
Okay, our next category is Outstanding Technology Innovation. These teams developed an open source generative AI tool in novel ways to provide new insights into large language models and rules as code implementations. Our first winner is Policy Engine. Team award, sorry. Our next team award is Palms and Circumstance.
Our next category is excellence in design simplicity. First category is Lightbend, who are our virtual presenters, so congrats to you all online. Next up is our ragtag snappers. And lastly, Tech 2I.
All right, our next category is outstanding experiment design and documentation. As a professor, you know, that's near and dear to professors' hearts. Our first team winner is Code the Dream. And this next one is the Hoyas Lexicodex.
And our last category before community of choice is excellence in equity. These teams demonstrated excellence in their considerations of equity and the people who may use their tools. First up is our M-Relief team. And also our Nava team. You guys could probably guess. All right, Tina should come up and announce community choice. Tina's our community advisor who keeps all of the Rules as Code show running.
Amazing. So the number one.
Thank you, everyone. Amazing job. The number one community choice is Code the Dream.